Welcome to Lecture 12 of Networks, Friends, Money, and Bytes. And today's question is a follow-up on the question we saw last lecture. Back then, we looked at why am I being charged $10 a gigabyte in certain markets. And now we're going to look at how can I pay less for each gigabyte. Now, before we go into this very practical question, we'd like to highlight that the field of network economics is a broad one. We have been focusing on the specific area called network access pricing. For example, on the mobile cellular network. There are quite a few other important areas in this field, including the interactions between ISPs and ISPs. In the next lecture, we'll look at the inter-ISP agreements, the interaction between internet service providers and the content distribution network, for example, between AT&T and Akamai, and the interaction between vendors such as Apple of cell phones, iPhones and iPads, and the ISPs. The way that they arrange payments agreements are very interesting to examine. Another topic is the proliferation and demise of technologies, trying to look at the economic and the networking technology aspects of these trends. Yet another important area is the decisions of making certain investment. These can range from purchasing spectrum for 3G or 4G network, and these can cost tens of billions of dollars for each auction, to the adoption of certain, say, security or new access technologies. Okay. So access pricing, interaction among the ISP, CDN, and vendors, the modeling of the rise and fall of technologies, and the decision of investments, they all can benefit from our understanding of network economics. And this field is interesting in part because it's a two-way street. New network technologies can rewrite the balance equations in the economic modeling. At the same time, economic forces shape the rise and fall of network technologies. It is also a challenging field, mostly because data is very difficult to obtain. Whether these are the data about the cost or revenue models of the ISPs, or these are the, say, data of consumer behavior. For this kind of data, we need proprietary information from the industry. For this kind of data, we need to carry out realistic consumer trials. We'll see some of these challenges being met later in today's lecture. So now let's look at specifically access pricing. Now, access could be access for voice or access for data. And our focus is on data, so we call this data pricing. Now, we have seen data pricing. In the last lecture, we have seen flat rate data pricing. We have seen usage-based data pricing. And we're going to see some interesting extension that we collectively call the smart data pricing. So this is an umbrella term, and there are many different meanings of this term. We're going to look at a few of them in this overview module of the lecture. Now, one is an hourly accounting-based data pricing. Instead of looking at how much you have used, it looks at how long have been using it. Okay. Another one is priority pricing. This says instead of asking how much you should charge, you ask what to charge. For example, if I offer a premium service, okay, maybe I can charge more. In some of the countries, you have what's called anti-throttling. Now, throttling is reduction of transmission speed. Anti-throttling says that I will boost your speed, or a booster button, okay, if you're willing to pay more. There are also other kinds of answers to this question, what to charge. For example, while you know that a different product will lead to different prices, it turns out that you can also charge different prices, and that will automatically differentiate the products into different tiers. In the advanced material part of the lecture, we will look at an example of that called the Paris Metro pricing, okay, where you label the same cars in the metro subway service into premium or first class versus normal or coach class, and set the different prices. It turns out that by charging the same product differently, actually you differentiate the product, as long as consumers' utility depends on the congestion or utilization level of the service. Yet another variation is whom to charge. So far we have assumed that the ISPs will charge you and me, the consumers. But there are also notable exceptions. For example, the 1-800 number in the US, and similar kind of idea with different numbers in other countries, is a big success of creating win-win across the callers and the callees. Instead of you paying, okay, you call 1-800 number, you don't pay. Back in the old days, calling long distance can be quite expensive, even on landline. Instead, the other side will pay for it. Why would the other side be interested in paying for it? Because they would like to sell you something else, another service or product. So similarly, you can think of what's called 1-800 number for mobile data or sponsored content. Now, this is not identical to Google's sponsored content or ad space auction on their search page. But the idea is that instead of consumers paying for the content or app provider may be able to chip in part of that and subsidize the consumers. Okay? And when the elasticity is just right, the volume increase will overcompensate for the amount of rewards that you provide to the consumers. So it could be a win-win for everyone. Okay? Yet another answer is to the question of how to charge. Okay. You may say that instead of charging everything the same, I may say certain applications I would charge less. This may depend on the kind of applications. Okay. Certain application may occupy a lot of capacity. And related to that is the idea of congestion-dependent pricing. It says if the network, here's a pipe, in the network, and in general there are many such pipes. Okay. I look at this network and I say maybe this part is very congested, so all those flows that go through this path should pay more. Okay. Whereas the flows that go through other paths that are not congested, they don't need to pay as much because they are not really competing against many others, and there's more capacity than they need anyway. So, for example, this can be location dependent. Certain locations are just so crowded that your presence presents a strong negative externalities to the other. Or it could be time dependent. At a certain time of the day, the network is not in much use and there's no opportunity to call. So go ahead, I would charge you much less, or maybe even free. A typical idea is the nighttime versus daytime tariff or pricing for voice calls. Nowadays, the carriers, at least in the US, are trying to switch from limited data, limited voice, and unlimited data to the other end into limited data and unlimited voice, because they realize it's the mobile data traffic that's driving their cost revenue equation. Okay. But back in the old days, you get unlimited data, but your voice minutes are limited. However, night times and weekends don't count. So that's a simple static and two period. So there's just a nighttime and daytime. It's static because you predefine what is nighttime and weekend. And the price, well, the price is 0 because it's free. Daytime will count towards your fixed quota. Okay. That is a simple case of time-dependent. Static pricing, we'll look at time-dependent dynamic pricing with multiple periods coming up. So whether it's location-dependent or time-dependent, eventually it can evolve into congestion-dependent. Look at the particular time and location and decide the price based on the congestion condition. So the phrase SDP, Smart Data Pricing, refers to any of these. Okay. Hourly based, priority pricing, implemented by a variety of mechanisms such as Paris Metro pricing, two-sided pricing or 1-800 number generalization of sponsored content, or application of congestion-dependent pricing. Now today we will be soon focusing on just one specific case, time-dependent pricing. We'll go into a little bit of detail of this one member of the family of SDP, and then advanced material will say a few words about priority pricing and two-sided pricing. But before going into any of these, we want to highlight again the difference between static and dynamic pricing in our terminology. When we say pricing is static, it doesn't mean that we charge the same thing to all the people all the time. It simply says that we have a predefined, fixed definition of time slots that's predetermined. And the price is also fixed, even though we can have different prices for different time slots. Okay. So the daytime versus nighttime and weekend time voice call tariff practiced by many U.S. carriers in the last decade falls into this kind of pricing. Okay. You fix the time slots, you fix the price, which may change, but very slowly. Maybe once a year or once a couple of years, the carriers may decide to move the price. But it is a much longer time scale than, say, a monthly bill basis. Okay? You can have different prices. It's just that the prices are predefined, fixed for fixed time slot definition. Now, in contrast, dynamic pricing says that the price at different time slots can change at a fast time scale. Or alternatively, you can say that you are not even defining or predetermining the notion of time slot. You can say that, well, today, 8 p.m., it is $10 a gigabyte, but tomorrow's 8 p.m. may be $9 a gigabyte. Okay. Now, how fast is the time scale? It got to be faster than, say, the monthly bills time scale, which is monthly. Okay. But there are choices. Now you can say, I will do day ahead. I will announce the price, at least for this location, or maybe for this area of locations that you're likely going to be situated in 1 day ahead of time, so you can prepare for it. But you can also say, I don't announce a day ahead, I do spot pricing, meaning that I will price right on the spot. I don't announce it any day ahead, maybe 1 second ahead or something. Another dimension of time scale is what's the granularity. Now the granularity here of a duration in which the price is held the same. It could be, say, 30 minutes, okay? Or it could be 1 minute. It could be maybe 2 seconds. Now anything below that, it might be infeasible just to go through all the signaling that control this billing process. But you can go down from hours and minutes all the way down to seconds. Now, of course, as you go down further to seconds, you better make sure that you have autopilot without human interactions, and that you are basically going into from time dependent to congestion dependent pricing. Okay, you're looking at instantaneous congestion condition. So all of these are examples of dynamic pricing in contrast to static pricing. Clearly, dynamic pricing are more general and more powerful, but it also suffers a potential risk of complicated message to the consumers. So we must have a very simple user interface, UI. And in fact, as we will later discuss, you can have a dynamic pricing, but not dynamically viewed by consumers. There are many ways to hide the complexity of dynamic changes from the consumers so that they do not have to be bothered, even though they are given the power to choose among alternatives. So the ideal win-win situation through SDP is the following, that the carriers or internet service providers will generate more revenue, reduce cost, and lower the churn because the consumers are happier. The consumers at the same time will be able to pay less for each gigabyte. Now, what is the catch here? Consumers pays ISP, how can they both be happier? Well, the consumers may be paying less for each gigabyte. Say instead of $10 a gigabyte, on average, let's say you pay $5 a gigabyte, you think that you are getting a much better deal. At the same time, if they consume more in general without incurring more cost to the ISP infrastructure, then the ISP gets more revenue, lower or the same cost, and thereby increasing their profit. This also implies that the content providers in such a win-win will attract more eyeballs and therefore afford a better subscription or a mobile advertising revenue. And the vendors will be able to sell more innovative hardware and software. So the question is, how can we achieve such a wonderful win-win? How can we go from the current state, which is $10 a gigabyte, to such a win-win through different smart data pricing SDP? Now we will look at a specific case called time-dependent pricing in most of the rest of this lecture, and then advanced material go into a couple of other topics.